Okay. So how many of you have heard this term service oriented architecture or SOA? How many of you have heard this term service oriented architecture or SOA? Okay. I see some of the hands raised. Because this will help me to decide from what angle I should explain. Right, so that's why I'm just asking your opinion on it. Okay. Okay. Okay, some of you are telling we don't know anything other than the name. Okay, fine. So let us start. See, simply put, SOA is nothing but it is a architectural style. Okay, just like how there are different architectures to build a house, just like how there are different architectures to build anything in general. Okay. Is everybody able to hear me? Can everyone hear me now? There was a small network glitch here. Can everyone hear me now? Please raise your hands. Is everyone able to hear now? Sorry about that. There was a small network snitch. I think it is resolved now. Okay. Sorry for the interruption. So coming back to where we stopped. So just like how you have a particular architectural style to build a house or to build anything in general. Anything in general is built using some architecture. Same way, a service-oriented architecture is nothing but, like the name suggests, SOA, service-oriented architecture. It is architecture, but just that it applies not to buildings. Instead, it applies to a set of software or a set of software services which are offered by an organization. See, an organization can have a lot of software service components, and these components can offer different service or different functionality based upon how they were designed. Right? So this design based services, how they all work together to accomplish a complete business process. That architecture is designed or it is derived by using the service architecture. So what does this actually tell? That is the next question. So the first thing we know is it is just an architecture or a layout plan that is applicable to a group of software components which offer some services. So the thing here is how this what this architecture suggests about such kind of software components or services. See, the basic goal or the primary motto of service-oriented architecture is independency, or in more technical terms it is called as loose coupling. Okay, that is, if I have 10 components that do some various activities to offer a business process X, I make sure that these 10 components are independent of each other. That means in case component 1, 7 and 9 fails, right, my other components will still remain working. That means at any point of time I will not be completely shut down. I will be able to do at least part of my work. Is everybody getting this? Please raise your hands. Is everyone getting what I said till now? Okay. Right. Right. So, okay, some of them are saying repeat. See, if there are 10 service components or software components, assume you can, for people who are from a functional testing background or a manual testing background, can assume this functional components to be 10 different modules. Okay, so these 10 different modules are designed in such a way that they are going to be totally independent of each other. That means if modules 1, 7 and 9 fails, it will not stop the working of the other modules. Okay, so this way of designing your software components, okay, to be independent of each other in order to offer a business process, is called as your loose coupling or independency. This is the primary goal. The need, see, if you ask why should a system have loose coupling and all, see, right now it is a very, very rapid development environment. Everything is changing overnight. Assume that there is a simple banking service that a company offers. Okay, a very simple banking service. The banking service is covered by 10 different software components. Or let us say for now 5 different software components. So one is account creation component. 2 is deposit component. 3 is withdrawal component, and 4 is balance inquiry component, and 5 is loan component. Okay, if the company has a service oriented architecture in place, then if for some reason if the deposit component is not working, that doesn't mean my account creation or withdrawal or balance inquiry component will not work. It will work. Okay, if loan component is not working, that doesn't mean the other 4 components will have an issue. They will keep working. This type of independency among different components in a normal functional design, these components will be called as modules, but here they are called as software components or software services. That's all. The difference lies in the terminology and the architecture. Okay, so the basic goal is, if I go and do some change in deposit component today, and the change makes my deposit component or deposit software component or deposit service unavailable for 3 hours, that will not and should not affect the other components or the other software components or the other software service. This is the basic logic. So if you have a valid proof tested service oriented architecture in place in your company, then your system becomes very adaptable to changes, because when one component is under change, or it is going through some change issues, or it is going through some problems, that will not affect the other components working, right? Given that is said, let us dig a little deeper. So like I said, the goal is to achieve loose coupling, right? When I say loose coupling, I'm not talking about components that do not interact with each other at all. Components that do not interact with each other are by default loosely coupled, because they don't have to bother about each other, because they don't have interaction, right? So on the other hand, components that are supposed to interact, if you are able to loose couple them or make them independent of each other, that is what is your SoA architecture going to teach you, right? Why this is needed is because it is easy to make any configuration change for any component, and it is very flexible, because later if I don't have a deposit component, that is not going to stop my banking service from working. It will still work, but without the deposit component. That type of independency is possible if you are implementing service oriented architecture, right? So like the name suggests, now let us come to the name. Yes, okay. So it is service oriented architecture. Right now we have just seen the explanation for architecture, because it arranges our architectures or designs how your software components are organized. Okay. Independently. That is what we have seen till now. Now let me come to this service oriented part, that is a single text. Let me come there. See, as far as SoA is concerned, it assumes that a large software is nothing but it is a service. It is offering some functionality. Here a functionality is called as a service. So inside a service oriented architecture, every software component is said to be a service, because the functionality offered by a particular component, functional component inside SoA is called as a service. So you need not think that this is some out of the blue term. Here functionality is called as service, and the functional module is called as service component. Alright. So the way you organize these components will make, if it makes them independent of each other, though they have to share some data or some type of interaction, then you have achieved service oriented architecture. Okay. So now let us get in further a little deeper. The benefits of service oriented architecture, you might not get them right now, but in the long run, a benefit that service oriented architecture allows you to get is, it is easy to integrate new components, because like we said, the addition or removal or editing of any of the existing components will not affect the working of other components. The other components will remain undisturbed. They will not be disturbed at all. Right? And it increases reusability, because components that have common functionality can be reused, and at any point of time only the problematic components won't work. So it reduces your business risk. and it is easy to adapt also. That we will see how, right? So there are some important points to remember before we proceed further. SOA is a evolution. That is, when I say evolution, like how it is applicable for any living organism, like human beings who evolve from being a child to a infant to a teenager to a middle-aged man to a old-aged guy. Same way, SOA implementation is a evolution. It grows slowly over time. It cannot happen on the fly, it cannot happen over a night, right? So when you know that your components or your modules are capable of being loosely coupled, only then you can use SOA. That is important, right? So someone asked, will testing software and SOA differ? There are not much of differences, but there are certain very primary differences which we will see as we go on. Okay, I'll be pointing them out, right? So what happens here is, if you have a single loosely coupled service, you can still have it as a service on its own, like our web services, right? So your web services are a simple, straightforward example of a single service component. On the other hand, if multiple service components interact together to give you some composite functionality, then they are called as composite service. A lot of loosely coupled services which work together to give a single service is called as composite service, right? So so someone asked me, that means after any modification done in one component, we don't have to do regression testing. You don't have to do regression testing in the level that we do for a normal functional application. In a SOA architecture, there are certain areas which you have to concentrate while you are adding a new component. Only that much is enough. It will not be in depth like how you do for a normal functional software, right? We have a PPT on SOA test plan, which I think probably will start off in tomorrow's session if possible, right? And we will be able to cover that. In that we will be able to cover about the test plan, how the testing is done, and so on. So someone says, can you show me the previous slide once? Okay. Are you referring to this benefits of SOA? You need not copy this thing because you will be getting all this, so you need not copy these things basically. Since we have less time, just proceeding forward, right? So services that are loosely coupled together to offer a bigger or a composite service will fall under the composite service category. A composite service is nothing but it is like many individual bricks forming a house, many individual services offering a very higher level of service. That is a composite service. So a service should have a standard complaint interface which will help it to integrate in a very, very easy way. That means if I have 4 different components in which offer a particular service, say the banking example itself, all the components that work together to offer the banking service should have a same type of interface, that is a same way of connecting or interacting with other components. If that interaction, the mode of interaction differs for each and every component, then they are not actually a good candidate for loose coupling, right? The basic premise of loose coupling is that these components are standard in certain ways, like the way in which they interact with each other, right? The way in which they all share and interact information. Those things should be compiled. Those things should be standard. That is why I've made this as a point to remember, right? So the overall philosophy of the service oriented architecture is business decides what services you give, and your services will decide what technology you should use. Basically, you should analyze whether my particular application or my business is a good candidate for SOA or not. Right? So now moving on, we are going to see the components of SOA. Before I proceed further, till this, is everybody clear? Is everyone clear till this? Okay, someone says yes. Okay. Okay. So some of you have said yes. Someone asked loosely coupled means. I have been telling that from the start. Please have a closer look at it now. See, loose coupling means nothing but making your service components or your software components being extremely independent of each other. That means if component A and B are together present in a software, and if suppose one day component B fails, that will not affect my component A from failing. Any failure for a submodule in your software should not affect any other submodule. That is called as loose coupling. Am I clear? Okay, am I clear? Okay, right. Okay, so now let us proceed to the components of SOA. This is important, so pay close attention to this. Okay, see, there are three basic components of service oriented architecture. This is very important for you to understand. Only then you will be able to understand how web services are becoming a part of SOA. So here there are three guys who are going to come into picture. Assume that you want to buy a gift for somebody, okay, online. You want to buy a gift for somebody online. Say you want to buy a wallet, okay, for someone, right? So you want to choose a good online site and you want to purchase your wallet from there. So what you do first, you go to Google, you type online shopping. So it gives you a lot of results like eBay, Flipkart, etc. And once you are okay with selecting a particular thing, say you select eBay or Flipkart, and then you go to Flipkart site, accept to the terms and conditions, and then purchase your wallet. Is everybody agreeing with this process? Is everybody agreeing with this process? Okay, yes, right. So here, when you say that you are going to have this kind of setup for purchasing a wallet, similarly for a service, for a web service or a service component which is going to be a part of service oriented architecture, there are three such things, okay, or three such components. One is the service provider. He is the guy who technically designs the web services and makes them into a service oriented architecture. And then the consumer, that is the client, and then the service registry. So what happens is all pre-established or pre-defined services are published inside the service registry. You can assume the service registry as Google in our example of wallet purchase, right? So all the details of the service providers who offers various web services are present in the service registry. And what happens is, as a customer, you go and search for a particular type of service, say currency converter or weather forecast. You go and search for that in a service registry. And the service registry shows most of the service providers who comply with the search text that you have provided. And then you discover a service that is applicable to you, and then you accept the terms and conditions with that particular service provider and start invoking or using that service. This is how every single service component inside a service-oriented architecture will be used. There will be something called a service registry, which will have details of various services that are present inside your service-oriented architecture, and the customer goes and discovers or finds out the service that he wants at that point of time, and then he binds himself with the service provider based upon the license money he pays or any terms and conditions he has accepted, and then he starts using the service. This is how your service-oriented architecture is going to have its components organized. Is this clear? Okay. Some of you have asked me to repeat, and some of you are asking questions like, service registry is like Google and service provider is like website. Yes, you are right. Right. So let me repeat it again. A service registry is nothing but it is a collection of all the different web services that are a part of a composite web service or a service oriented architecture. It can be local to a company SOA also. A company SOA is a kind of is going to have a kind of service registry. Okay, the service registry can be thought of as a collection of your published web services. In other terms, I could say it is a collection of published web services. It is not going to be exactly a database, but it is, you can say it is a database kind. Because it is not, it does not have organized structure like a database, but it has only information on the service description, and the service provider. That's all. So when you go and enter a text like a currency converter or weather, when that service description is going to be present inside the service provider, he will reply you with all the services that comply with the search text that you have given, right? So once you search for a service and you select a service, you accept for the terms and conditions with the service provider, who is the end designer of the service or the provider of the service itself, and you start using the service. So this three interaction is definitely going to be present in any service oriented architecture. And this is the primary point of communication between the different components of SOA. Is this clear? Okay. Is this clear? Someone says yes. Someone says, what is publish? Publish is nothing but once the service provider creates a web service, he goes and publishes his service or adds the details of his service to the service registry. That is called publish. Okay. So now, given that we know these are the components of service oriented architecture, you have to understand first what test model will apply for the service-oriented architecture. Okay, we'll dig deeper into service-oriented architecture also. But before that, let me make it clear to people who are new to service-oriented architecture about the model of testing that is applicable for your SOA. Okay, so how many of you have heard of a testing model called V model? How many of you have heard of a testing model called V model? Okay, I see some hands raised. Okay. Okay. Okay.